All right, now these library projects really require an Intel processor, so I'm getting that machine ready. So I'm going to skip them and come back to them later. But we'll do some more debugging with Ali Debug. This is really very good, and this will work on the ARM-based machine. So the first one I ought to mention is if you want to learn assembly code, one really nice tool is Jasmine, and that's on the desktop here, Jasmine. This is a Java-based emulator of 32-bit Intel assembly code. So you can make a new file here, and there we are. And now you can just put in commands like move EAX1 and move EBX2 and push EAX and push EBX and so on. And this is just plain text. You can just copy it. And here's the pointer to show the current command. And you can execute all the commands or you can step through it one at a time. And so here's the registers, A, B, C, and D. So if I execute the first command, it puts a 1 in that register. And the next command puts a 2 in that register. The next command is going to push EAX onto the stack. And here's memory on the right. So the stack is at the bottom, and there it's pushed a 1 onto the stack. And when I do the next command, it's going to push a 2 onto the stack. So you can just process these, and each one of these commands has syntax highlighting, so you see how it looks, and it has a little description of the command here. So I give students projects where they have to run simple assembly language programs here and see how they work. This is a really good way to introduce beginners to how assembly language works. So I'll mention that one. That's a fun one to try. And but the main thing we're going to do is this one here, exe hacking with Ali debug. So the first thing we're going to do is we're going to modify PuTTY. We already played with PuTTY earlier and already downloaded the particular version of PuTTY that I like to use for these projects. Not that there's anything special about it, but if you have to use that version if you want to find the right flags. So it's here, PuTTY. All right. So you load PuTTY and Ali debug, and now what we'd like to do is change the message. Yeah, when it comes to Windows assembly, well, yeah, I actually taught a course in assembly language, so it's better. And I used to write assembly code on the Commodore 64 long ago, so I like assembly. But my students sort of freak out when they see it, assembly language for the first time, so it's good to have a sort of gentle introduction for it. So now what we want to do is we want to find the code that writes login as. So there's a feature in Ollie, which I haven't found in other debuggers, which is really great, called Search for All Referenced Text Strings. This will find not just strings, but strings that are actually used as arguments in library calls, which is very handy. Let me get the font set to be big. All right, and now we're just going to look for that string. Edit, find. I guess Control F will do it. I'm not sure where they hit it. A right click find will do it. There, search for text. I'm going to search for login as. There. It looks like I still spelled it wrong. All right. Login as. And by the way, when you search, make sure you're looking in putty.exe. It's easy to get confused and search a part of memory instead. So it found, uh, didn't find it. That makes me a little nervous. Text strings referenced in putty.text. Search for login as. There, okay, I guess I had to hit that entire. No, it's there, it found it here. There, ASCII login as. There we are. 4017053, that's one of them. And if I search again, I find another one at 41CB6E. And I don't know which one of these is the one that prints that message. So I put a breakpoint on it with the F2 key, and I go back to the other one, which I can do, I think, just search next. Yeah, I got to go back to the top. It searches downward. So I'll go back to the top. I want to find the other one. Right click, search next. There's the other one. And I use F2 there. So now these two commands that push that onto the stack to use it in, I put breakpoints on both of them because I don't know which one of them actually draws the code I'm interested in. And now I can return to the CPU window and now I can just run the program. So I run it and it's going to launch down here. And now I have to proceed to that point, which is going to be, I have to put in the name of a server like ad.samsclass.info and then press OK. Now it's going to pop up that box and get ready to print login as, and here it's hit the breakpoint, 41CB6E. So now I know which command prints that string. And there, you can see it here. So this is the one that prints it. That's what I wanted to know. So now that I've done that, I don't need the breakpoints anymore. So I can clear them. I'll just go back to the other window to do that. I guess I could do it a lot of ways, but now I can press F2 to clear this one. And I can go find the other one and clear it, or I can use, I think there's a debug. There's a way to clear all breakpoints up here someplace, but I'm not too much bother to find it up there. I'll just do that search again. Search next. Search next. There we are. Then F2 to clear that one. Okay, so now I've gotten rid of the breakpoints. I don't need these reference text strings anymore. I'm here. I now know that this address, 41CB6E, is the one that has the command I wish to change. So now let me just get my instructions open in a different window so I can more easily refer to them. Which is going to be here and here. Okay, and now, okay. I found the code. I used breakpoints to find it. All right, now I want to alter the login message. So the first thing I'm going to do is just remove the first letter from the message. So notice here, it pushes this address 467C7C onto the stack. If you right click, you can follow in dump immediate constant. And that will show you that area of memory. Here's 467C7C. So here it is spelling out login as colon and then a null to terminate it. So if I change this one byte here from 7C to 7D, it'll start at the O instead of the L. So you can do that by just right-click Assemble or Spacebar, and now you can change that instruction. So I'm going to change it from 7C to 7D and click Assemble and then cancel. And see, now it's going to tell me now it's login as, because it's going to start here and proceed until it hits the null pointer. So now the message is different. So now, one thing I've learned in Ollie Debug is when you make a change, if you want to save a modified program, save it after every individual change. Otherwise, it's very easy to get confused and end up making a mess. So I'm going to export this thing if I can figure out how. Copy to executable, all modifications. This is where Ollie Debug is very cruel. When it says all modifications, what it really means is all modifications in this segment. So all the modifications you made in the text segment will be changed. But if you change the data in the lower portion, that would not be saved. That's why I've learned just save it after each change or you will go mad. If you make several changes and save it, they might not all be saved. When it says all modifications, it doesn't really mean all modifications. So copy all to an executable file, right-click and save file, and I'm going to call this putty2.exe. All right. All right. And now, if I run putty2, which is here in my downloads folder. All right. And then I give it the name of a server, ad.samsclass.info, and open. Now it prints the message login as with the L missing. Now this, by the way, should be pretty disturbing. You don't want people modifying code. I could have added malware to that. And when I first did this, I rebelled. I said, wait a minute. I thought this was solved decades ago in computers. We're supposed to have signed code. And here's a fun fact. This code is signed. If you go to Properties and look, there's a tab called Digital Signatures. And it tells you this thing was written by somebody named Simon Tatum. And when you look at the details, it will tell you the signature is okay. There's a digital signature on this code. And the digital signature should mean you're not allowed to modify that code. That's right. But Sable's saying, I don't want people to be able to modify that code. I shouldn't be able to modify it and run it. If you look at Putty 2 and go to Properties Um, the digital signatures tab is there. It looks the same. When you go to details, it tells you the digital signature is not valid. But when you run it, it doesn't even pop up a warning box or anything. It just runs. And I've shown this and talked to Microsoft developers, and they've tried to explain to me why this makes sense. And I really didn't understand it. I know. Well, I thought the whole point of code signing was that you couldn't run signed code that had been modified. But I don't know what good it's doing me at all. In my opinion, it should at the very least pop up a warning box, like from Windows Defender saying, hey, this file looks suspicious. The signature is invalid, at the very least. But it doesn't complain at all. And this is the latest version of Windows. So I'm confused. But anyway, that's what's happening. So we can modify it that way. And now we can also modify it to print a different message. Um, let's see. Yep, that's okay. Now we can change it to badness 7D. So let's take the modified file and modify it again. I'm going to close it here. Um, all right. I'm going to close this. All right. And I'd like to close that. Maybe I'll just close Ollie entirely. That'll do it. Okay. Let me relaunch Ollie. All right. And let's take Putty 2 and modify it further. Putty 2. All right. And now I can right click, go to expression, and it's 4-1. I've done this so often, I think I got this memorized. C6BE. Nope, I got it wrong. Okay. It's 4-1 CB6E. Okay. 4-1 CB6E. Okay. All right. CB6E. There we are. That's the place where it pushes login as. All right. So now I'm going to do the other kind of modification. I'm going to follow this, follow in dump immediate constant. That shows me the data. And now I'm going to modify the data here. So I highlight the data and right click, binary edit. And now I can change it by typing in a new message. And I'm going to put in badness there. And yep. All right. And click OK. So now this text has changed. And now I'm going to save it. And to save it, I have to right click down here because that's where the modifications are. So right click down here and copy to executable file. And now right click a save file. And that's going to be Putty 3. All right. And when we run that one, Putty 3, again, it doesn't warn me or anything. Give it the name of a server, open, and now the prompt is badness. So, all right. So that's the first few things you can do. That shows you how you can modify things. All right, and now we're going to play with some different files, and these came from a thing. There was a capture the flag contest called Easy CTF, which was intended for high school students, and holy cow, they were not easy at all. What you're going to, this is a small portion of one of the challenges I solved with great difficulty in that capture the flag contest. Let's take a look at it. There's this program called 000.exe. There it is. Good. Okay, it's downloaded and run. Okay, so let me go to my downloads folder. And there it is, 000.exe. Okay, so this is a command line game. Let's just open a terminal and go into downloads. Okay, and just directory will show that I have a 000.exe so I can run it. And when you run it, it asks you for launch codes. You put in a number, and then it insults you. I think my dog figured this out before you. I don't know. Maybe I can try again. No, I think it's just done. All right. It just didn't close properly at the end. All right. So this is a guessing game, and I don't know how to guess. So we're going to cheat at this game. Ollie, we open up Ollie Debug, and we open up that program in Ollie Debug, which is 000. All right, and there's the game running, and here's the code. And the amazing thing about this game, why this is such a wonderful teaching tool, this game was obviously written in assembly language because it's incredibly easy to understand in assembly language. The whole game fits pretty much on just one screen here. If I shrink these other panes, it'll be easier. There we are. And so, yep, that's it. This is the whole game, is what, about 20 or 30 lines of assembly code. And if you look at the right, Ollie Debug even shows you the story. You can see the library calls it makes. So it calls puts to print the prompt launch code. It calls scanf to read a decimal number from the user. And then it calls, does something here, and then it prints either wow, you got it, or I think my dog figured it out. So you can see in here, it does a comparison and then a jump. So clearly, this comparison is telling you whether you got it right. And this jump is going to go to 4025A, which is here, and that's going to print the insulting message. So if it does this comparison and it fails, it'll form this jump and then give you the error, the message saying you failed. So if I want to cheat at this game, all I have to do is not do the comparison and not do the jump. So I can just fill these with NOP. Just right click, assemble, and replace it with NOP, the command that does nothing. And then assemble, and then just keep on assembling until I get down to the jump, and then fill that one out too. There. Now I've added 8 bytes of 90 in the middle of the program. I've now made a modified game that'll be a lot easier to win. I can right click, save as, copy to executable, all modifications, copy all, right click, save file, and that's going to be 000 mod. All right. And so now I go to my command line, go into downloads, go directory, and there's the 00 game and there's the modified 00 game. So if I run the modified game, and now I give it a launch codes of 1, I win, and I get my reward, which is 1 letter. So that's the game. Now the original contest had 68,000 of these, and you had to solve them all, and then you would get 68,000 characters, which was a program in the language JSFuck, which you may know. I'll just mention, as we say, if you aren't familiar, these are esoteric languages. The original esoteric language was brainfuck. And this is a language that is intended to be as difficult to understand as possible. And what it did was it simulated the Turing machine. Remember, the original Turing machine would just sit on a line and process 1 bit underneath it. And then it would move to 1 byte underneath. Then it can move to the right or the left and change the byte. So the brainfuck contains only 8 commands: increment the data pointer, increment the data pointer to the left, increment the byte at the data pointer by 1 or decrement it, output it, accept 1 byte of input, and move the instruction pointer to the left or to the right. And therefore, you can write programs in this language, and the programs look like this. That is Hello World. Add to the current value enough to turn it into an H, move to the right, turn this one into an E, move to the right, and so on. This is what programs look like, and the point was to be as difficult as possible. And there's another version of it called JSFuck, which is pretty interesting. And I never understood how this works, but this is alert 1. You can write JavaScript. This is perfectly valid JavaScript that contains nothing but punctuation marks. We had somebody in the class who's an expert in JavaScript. I've never understood why this works, but this is in fact a valid JavaScript program. Somehow, just with no variable names or constants or anything, you can do things. It's incredibly inefficient. It takes 1,700 characters to spell out alert parentheses 1. But that runs alert parentheses 1. So that's what the original one was. You get these single characters by solving each game. And after you had 68,000 of them, you would have a JSFuck program, which was in fact broken. And you had to go back and find the missing completed pairs here and fix the broken program. And then when you ran it, you got the flag. I think it might have took me a week to do it. But anyway, I thought the game was very interesting, a good thing to practice on. And I included a few examples here. You can do one the way I just did it. and then you can do 3, and then you can do 16, and then you can do 256. So if you want to do large numbers of them, you have to automate the process of patching it. And so I have an example of how to do that in a Python file here. Here's how I did it. Um, I wrote a Python program that would load it and then add data to it, um, knock out some of the code, and then write another program and then automatically run the next program. Automatic execution with Python, and process all the files in a directory. There are other ways to do it. Another way to do it would be to read the assembly code and figure out how to deduce the flag from the data, and then just read all the files and find the data. Anyway, it's a good set of escalating challenges for my students. Doing 1, anybody can do by just following the instructions. Doing 3 is pretty easy. Doing 19 or 256 is for your more advanced students that are willing to work harder. Anyway, so that's a fun one to practice. And I'll just mention the next one is kind of amazing. There's a hacking tool from a guy in New Zealand, originally called Mimi Cats. Now I think it's called Kiwi or something. And this is a really powerful hacking tool, really important. He keeps finding all the secrets on domain controllers, like the golden ticket. Domain controllers have Kerberos tickets, and there's a golden ticket, which is the master key for the entire domain. And if the golden ticket is compromised, your domain is shot, and you have to rebuild the whole domain controller to get rid of it. And he figured out how to steal the golden ticket over and over and over. And so he keeps on updating his tool to crack into Microsoft Windows Active Directory. But when I played with that tool, I saw an option called Minesweeper. Let's see, you could pull min cred from RAM. Yep, that's the kind of thing. So anyway, that pointed out to me it's easy to cheat at Minesweeper. So I made a version of Minesweeper you can download and play with, and you can totally cheat at Minesweeper by looking in the memory. So OllyDebug is here, and if you load Minesweeper, which is here, I called it MineSam, my modified version of Minesweeper, so it has some flags in it. And so if you run this game, it's going to open in another window, and there it is, loading. All right, in this game, you click on these boxes, and it tells you how many mines there are near each spot. So from these numbers, you can deduce where the mines are, and so on. So there I hit a mine and exploded them. Let me just close it and run it again so I can get an image, a better image to show you. If I run it again, all right, let's try debug, restart. It's what you do whenever anything bad happens in a debugger. That'll start it from the beginning again. Now run it. Okay, now I just want to get a little bit of information on the board. So there's a 1 down there. Okay, there's a bunch of 1s and 2s. That's what I wanted to show you. Now you can find that information in the memory map. If you view memory, okay, and now you find the memory being used by Minesweeper, which due to address space layout randomization, it's been moved. Here it is, MineSlam. Here's the data section of MineSam. If you dump that, you see a lot of data here. And if you just go down a page or two, here's the board. The board is pretty easy to spot. It has 10s at the border of the board, and then it has 41 for 1s and 42 for 2s. And so if you compare this to the board, there. See, I have 2 2s and then a bunch of 1s. Here's the 2 2s, here's a bunch of 1s, and the empty spaces are 0Fs and the 8Fs are the mines. So you can totally find the mines here by just looking in memory. And in this project, you write a little Python script that uses the tool to dump the memory, proc dump, which will dump the contents of memory, and then it hunts through the memory to find the board, and it draws in Python a drawing of the board showing you where the mines are to help you cheat. So anyway, it's kind of fun to do. And then there's some flags to find here at various levels of the board. So these give you practice using the debugger to cheat on games, which is a really good way to get started understanding how to read assembly code and modify it. So I'm going to stop this one.